Hi everybody, this is Mrs. Kim and I'm here with Mrs. Erling and Mr. Knox. And this section is Chapter 8, Section 1, called The Rock Cycle. It covers pages 268 through 271, and make sure you have your book in front of you and that you're taking notes, and pause at any time to go back and re-listen. The word geology means study of the earth. The prefix geo means earth. Ology is a study of. And geology is a study of the shapes and patterns of the earth. Erosion. Erosion is when water, running water, ice, rain, wind break down rocks and carry them away to different places. Another thing that could cause erosion is humans. When we drive over roads or walk on them, that could cause erosion.
As you guys know, the earth is made of rocks. Now there's three main types of rocks. There's what's called igneous rock, there's metamorphic rock, and sedimentary rock. And we're going to be learning about the three types of rocks in this chapter. The first type of rock is what we call igneous rock. This igneous rock was once liquid rock. It was very hot. It was developed in the center of the or middle of the earth. It was magma, and then it later erupted out of a volcano and cooled to become rock, or it could have almost come out of the Earth's crust and then cooled and became a rock there. And here we have three types of igneous rock. We have obsidian, sometimes it's called volcanic glass or black glass. The Aztecs used the, or Incas or Maya, one of those people, Mesoamericans I think they call them, used the obsidian for weapons. Okay, here we have an example of obsidian right here. You can see it can be cut and made into arrowheads, things like that, knives. A lot of scalpels, not a lot, but some of the scalpels that doctors use are made of obsidian too, but they're very expensive. So here we have obsidian, we have some lava right here. Eventually it's going to cool and become a rock, igneous rock. And some of you guys have granite countertops. That was lava at one time. It later cooled, become igneous rock called granite. So igneous rock, the main thing there was once was liquid rock and eventually cooled. The other type of rock is sedimentary rock. Now, sedimentary rock, as the name suggests, is sediment. Rock erodes and it breaks down into fine particles, and these particles eventually may end up in the sea, it may end up in the river, or may end up in the lake, and this sediment starts to build up. And as it builds up in the ocean, the sediment at the bottom kind of gets squished. It's like if you were at the beach, and if you've ever been buried in sand at the beach, you know all that sand's on your chest, and the more sand that builds up on your chest, the harder it is for you to breathe because you're getting crushed. Well, imagine a mile worth of sand on your chest. That you're going to be really squished. So that rock, sorry, that sediment under all that sediment. Sorry. Thanks, Mrs. Jenkins, for interrupting this awesome video. Now everybody knows that, Miss Fraley. All right, so back to the video, back to education. So that sediment that's been squished by all the sediment above it eventually over time turns to rock. This is why most fossils are found in sedimentary rock. And I'm going to let you guys discuss this, why you think most fossils would be found in sedimentary rock. So that's the second type of rock. The third type of rock is metamorphic rock. And the prefix morph means to change. So metamorphic rock was changed rock. So it was igneous rock at one time, then it changed. Or it was sedimentary rock at one time, then it changed. Or even it could be, this is mind-blowing, it could have been metamorphic rock and it changed again. So metamorphic rock is changed rock. How does it change? Through tremendous heat and pressure. And the only way this can occur is deep in the Earth's crust. The continents collide, that's a tremendous amount of pressure, tremendous amount of heat put on these rocks, and you can even see it kind of causes these rocks to bend. If you look carefully, You see the bend in those rocks. That's because of a tremendous amount of time, tremendous amount of heat, and tremendous amount of pressure that causes these rocks to change. The crystals in these rocks actually change because of all the heat and pressure.
So the rock cycle are forces inside Earth and at its surface, and it produces a cycle that builds, changes, and destroys rocks. So a rock is never just a rock. Any rock you see at the park, on the ground somewhere, that rock has gone through a cycle that has made it exactly the way you're seeing it. So could have started off as an igneous rock, and through weathering and erosion it broke down into sediments, eventually over time compacted and cemented to become a sedimentary rock. Or maybe it started off as a sedimentary rock and through heat and pressure became a metamorphic rock. Again, the metamorphic rock could break back down into sediments through weathering and erosion, or it could melt into magma and cool back down into an igneous rock. So over time, these rocks change in many different ways. Pathways of the rock cycle. So we have volcanic activity, which would be magma and lava. So magma is underneath the ground, molten rock from the core and mantle. Once it comes out of the volcano, it becomes lava. Erosion causes rock to wear away and break back down into sediments. Deposition, think of it like depositing or dropping off. So those sediments that were worn away by erosion are deposited, and over time they could build up. Heat and pressure changes rocks into metamorphic rocks. This happens deep underground. And sometimes rocks get so hot that they melt. And this, when it cools back down, it could turn into an igneous rock. Okay. All right. Here's Mrs. Kim.
So I want to go back to that question, why are most fossils found in sedimentary rock? Well, what would happen to an organism if it fell in lava, hot lava? It would probably melt or disappear. Same with metamorphic. If a lot of heat and pressure was put on the animal, the body's going to go away. So that's probably why we find most fossils in sedimentary rock, where sand or sediment just piles on top and they are preserved that way. Thank you.